Hello, and welcome to the Office of Global and Community Engagement's Forum on Global Affairs. My name is Fraser Turner, and I'm the Senior Director of Global Initiatives at Loyola University Chicago. I'm pleased to welcome an online audience for today's webinar from Loyola's campuses in the Chicagoland area, Rome, Italy, and across Loyola's global partner network. Welcome. Today's webinar marks the first in a series of live panel discussions in what is the latest series installment on the Forum on Global Affairs, Artificial Intelligence in a Globalized World. With this series, Loyola hopes to foster discussion about the implications of AI on a globalized world, shedding light on how AI is morphing societies, industries, and our core understandings of human interaction. The discourse around AI is inherently global. The series showcases interdisciplinary perspectives of Loyola faculty as leading academics in their field, while also highlighting the insights of fellow scholars, practitioners, and students from across the globe. This series is scheduled to span the course of the next year, and more information on the registration of future sessions and recordings of prior forum discussions can be found on Loyola's Global Engagement website. Today's kickoff panel, AI Foundations and Applications, will serve as a topical introduction and overview of the principles of AI, while also examining its historical foundations. Today's panel will be slightly different in structure from other panels in the past, in that it will be comprised entirely of faculty members from Loyola, each sharing their distinct area of expertise as it relates to AI. Each of today's panelists will also participate in leading future panel discussions in the series, while then bringing in voices from around the globe to contribute to the web-hosted panels over the next year. Lastly, I'd like to take a brief moment to thank the various offices and individuals who continue to make the Forum on Global Affairs possible, including each of today's panelists and their respective academic units. I would also like to expressly thank the team in Loyola's Office of Global Initiatives who have helped organize today's event and the new series in the Forum. It is now my pleasure to introduce today's panel moderator, Dr. George Thuravathikal. Dr. Thuravathikal is the department chairperson and professor of computer science at Loyola's College of Arts and Sciences. Dr. Thuravathikal is also a visiting computer scientist at Argonne National Laboratory, and whose list of publications, career accomplishments, and contributions to the field of computer science far exceed the time I've been allotted in this introduction to detail. Without further delay, I'd like to invite George to start today's panel and introduce the other panelists joining him. George, please take it away.
Okay. First of all, thank you, Fraser, for that very kind introduction. Thanks to Mary Usher as well in the Office of Loyola Global Initiatives. And thanks also to Loyola for, in general, for our efforts to bring visibility to the great work that we do in artificial intelligence, not just in computer science, but across the university. I've decided to just give a couple of slides to set the table on what this topic is about, with the intent of really, giving as non-technical an introduction to what artificial intelligence is, what machine learning is, and then I'm going to really turn things over relatively quickly to my esteemed group of panelists who will go into a lot more depth on these topics. I want to start with us understanding what artificial intelligence is all about. It's not a new field. This is a field that goes back multiple decades. And the first thing I just want to talk about is, what is it that we aim to do with artificial intelligence? The principal goal is to create machines that can perform tasks that require human intelligence ordinarily. Second, there are many different things we can do with artificial intelligence. Understand language, recognize patterns, make decisions, and also learn from experience. And this is what will characterize much of the machine learning era as well, is how do we actually build on what we know and be able to hopefully improve what we're seeing with the methods. The third is really to augment human capabilities and improve efficiency. I just want to get from the get-go to mention that many people are concerned that AI will replace everything. I'm not quite in that group of people that thinks it will happen soon. Maybe not even in my lifetime. We know there's going to be a great transformation that will take place nevertheless. So this means that we have to really learn to live with AI because it is here and we're going to be surrounded by it. Much like we were surrounded by other transformations that happened historically in science and technology. The web, if we remind ourselves briefly, was something that many people thought would change life in permanent ways. Many things that we thought, would be like perfectly safe jobs were going to be somehow transformed by the web itself. And before that, there were computers, which also automated many tasks, even without AI. So the other thing is, apart from all of the what I'd like to call workforce implications, there are applications of AI to fields such as healthcare and entertainment. Again, for decades, people have incorporated computational and machine learning methods, even in fields such as music. Okay, including like the rich history of electronic music, which introduced a lot of automation into music. If you're looking for kind of what fields are involved in driving this transformation that we're seeing, it's a blend primarily from a technical point of view here of computer science, mathematics and statistics, cognitive science and neuroscience, and engineering. And apart from all of that, as we see in our panel here, there is great interest, both in terms of cultural, like cultural historians, ethicists, people in communication, which will come up in our other panels, are greatly interested in living with and understanding the implications of AI. I want to also make sure that we understand that machine learning and artificial intelligence are different things, because these two, even among us in computer science, tend to be kind of conflated. Machine learning is really a branch of AI that is focused on the data-driven aspects of learning. And AI historically has also included many systems that are not as data-driven. For example, like logic and rule-based systems. These are tools that actually come historically from philosophy and mathematical logic. So a good number of these like expert and inferencing systems that were built in the earlier phases of AI history were largely built on these axiomatic type of systems, or what people often call symbolic systems. So machine learning is basically a good part of what AI is about, but it must be understood that it's not the only thing. And then machine learning is really something that depends very heavily on data. As Andrew Ng likes to put it, he's one of the major exponents of AI research today. ML is data hungry. It improves with experience, including improvements to algorithms that work with it. Dima will cover this in his talk, but this is kind of a changing picture with what's happening with deep reasoning, and also that it's getting harder and harder to keep relying on data because these models have seen so much data already. It's not that we'll ever run out of data completely, though, because new knowledge is constantly being created, and it's not being created with AI. It's also being created by actual humans. Okay, so the key types of machine learning, and I believe this will also come up in Dima's talk, is that we have supervised, unsupervised, and reinforcement learning. So you'll hear those terms. I won't define them at this time. And I want to also point out that beyond like what we call this kind of textual era of machine learning, we're seeing also that like the same kind of algorithms are being applied to deal with speech recognition, to deal with predictive analytics in general, to deal with computer vision, which is one of my areas of research, and robotics. So there is a lot of context for machine learning in general. And of course, you see many of these also in the various models coming from OpenAI and the other major providers of what I call foundation models, such as Meta and Google. However, it will take something much more than just generative AI to make progress in these other areas, especially computer vision and robotics. So that's a really key takeaway there, is that these are not the only, what we're seeing today with GPT-4 and beyond, because it's happening every day. There's something new. I mean, we just had Meta release its new models. These are not the only interesting applications of machine learning. And that's the takeaway I really want you to all walk away with. And it has great implications in a global world, in a global effort, simply because for AI to reach its full potential, it's going to require all of us. Much of what we see tends to be around kind of the Western or even English as a language, but these models all are being tuned to work with languages all around the world. And you see this especially in these ecosystems like Hugging Face. So that's really the basic background I wanted to provide on AI and machine learning. And this is just a glimpse of our agenda here. I have 4 wonderful panelists, as I mentioned, and I'm going to just briefly introduce all of them, and then we're going to just run this program uninterrupted until we get to the audience Q&A, assuming no technical snafus happen. So we're assuming no chat bots interrupt our presentation, I guess. But I have Dmitry Dligach, who is from the computer science department here at Loyola Chicago. I have Shulbika, who is from the leadership computing facility at Argonne National Laboratory, and also will be teaching for us in fall at part-time in the computer science department. I have Michael Burns from the biology department, who does work on computational biology. And I have Joe Brukoff from the philosophy department, who will help us to reset our expectations for this technology. Okay, so without further ado, I'm going to turn things over to Dmitry, and we'll go from there. Okay, Dmitry, you're muted.
Thank you very much. I'm Dmitry. I'm an associate professor at the Department of Computer Science. So I'm going to talk a little bit more about how AI works. So, and specifically, I'm going to focus on something called large language models. So what are these large language models, and what is the relationship between AI and large language models? So we're all familiar with large language models, things like ChatGPT, Claude, and DeepSeek R1. So these are examples of large language models, but large language models are AI technologies. So AI is this larger field, and LLMs are sort of an instance of different implementations of AI. So what exactly are large language models? I'm going to try to break it down. The large and language part are sort of less interesting. They're more easier to understand. But what is a model? So a model, in my mind, is a simplified representation or approximation of some system or process. So what are we approximating when we're building large language models? Well, we are approximating the entire internet. So we take most of the text that we can get, most of the internet, basically, about 10 terabyte of text. We need a lot of specialized hardware called GPUs, and we typically rent those GPUs. We pay millions of dollars, typically to train these large language models. And the result of that training is a file which contains the model. So basically an approximation of the entire internet. And that file is typically much smaller than the data that we trained it on. So we're going from 10 terabyte of text to about, let's say, 140 gigabytes of file. So there's a lot of compression going on. We have sort of a compressed representation of the internet. And what we're doing is we're teaching our model to perform a very simple task, to complete sentences roughly, to, given a sequence of words, predict the next word. So for instance, cat sat on a, and then the model should be able to tell us that the most likely next word is met, right? So a lot of the time you hear people say that, oh, LLMs are just doing next word prediction, they're dumb. This is just a fancy form of autocomplete. And when I hear this, I always think of this quote from Stephen King when he was asked how he wrote his first novel. His response was one word at a time. So you can do a lot by effectively just predicting what the next word in a sequence is going to be. So here's an example, right? So if you consume a lot of Wikipedia articles, right, and then you can complete sentences like Obama was born in Hawaii, right, and Obama graduated from wherever he's graduated from. Right, so if you can do that, then basically you've just absorbed a lot of useful world knowledge and you understand syntax and semantics of language. And those things are very important and very hard to achieve. But as I said, to train LLMs, you need text. And however surreal that sounds, there's a lot of talk now about the following, that we are basically running out of text. I attended a major AI conference called NeurIPS last December, and Ilya Sutskever, formerly of OpenAI, said that data is the fossil fuel of AI, and we used it all. So basically, we now think that we've used all the text data that we can get from the internet. So when people started to realize that, stock market plummeted because people thought that AI systems would no longer be able to improve because we basically ran out of training data. But turns out that there are other avenues that we can explore to make models better. So I'm talking about reasoning. So reasoning basically involves doing something slightly more involved than just predicting what the next word is. Turns out that if you let models to keep predicting the next word and then the one after that and then the one after that, they can solve much harder tasks. So they can basically do reasoning. So if you let models to think before they give you the final answer, they can solve harder problems. And this is done typically using a technique called reinforcement learning. Reinforcement learning is learning by trial and error, and typically you train these systems by giving them a metaphorical cookie if they manage to solve a problem. So you let systems explore, try different things, and eventually if they get the solution, you reinforce it. You give it some form of reinforcement. All right, so a couple months ago, a Chinese company called DeepSeek released a model called R1, and one interesting thing about this model was that it was trained using purely reinforcement learning. So the model was allowed to effectively try different things, explore, and it learned to solve very complex reasoning problems. Another thing about DeepSeek that you should be aware of is that it costs substantially less to develop. So we're talking about a fraction of the cost that AI labs in the United States used to train their models. And so stock market plunged again because everyone thought that, oh, okay, maybe we don't need to invest so much money into AI, and we can achieve AI with a lot less. Okay, a couple words about reinforcement learning. Okay, I'm almost out of time, I think at this point. So maybe, okay, I'll skip reinforcement learning. I'll just say that reinforcement learning, there's a lot of speculation that reinforcement learning will lead us to AGI and ASI. AGI stands for artificial general intelligence. ASI is artificial superintelligence. We don't know if that is the case. We're running this experiment now, and I guess we'll know soon. And in conclusion, I want to say that my home department, computer science, offers a number of very high-quality AI courses, machine learning, natural language processing, deep learning, large language models. So feel free to take our classes. Okay.
Big Picker would be next.
Can you all see my screen? Okay, good. Hello, everyone. I'm Shilpika. Today, I'll be presenting the topic on prompt engineering and linguistic principles of interacting effectively with LLMs. So now let's dive into what prompt engineering means. Before that, what do we mean by a prompt? A prompt is a question or statement to effectively communicate with AI. And in this case, we are talking about large language models or LLMs. Prompt engineering is a nuanced practice that involves formulating these questions or statements that allows us to communicate with the LLMs. So it's a blend of analytical thinking and creativity essential for translating human intentions into a language that AI can process and respond to accurately. Now, in prompt engineering, linguistics plays a key role. Understanding the nuances of a language and how it's used in different contexts is crucial for creating effective prompts. Additionally, knowing how to use grammar and language structure that is universally used will result in AI systems returning back the most accurate responses. Now, we know that LLMs are trained on vast amounts of text data from our previous talk, and LLMs end up learning patterns, grammar, semantics, and knowledge from this data. But despite their extensive training, LLMs may not inherently understand the specific goals or context of a user's query. And prompt engineering bridges this gap by allowing us to craft prompts that effectively communicate the user's intent to the model. In a way, you align the prompt with the model's learned patterns and knowledge. All right, we want to make sure that we formulate a prompt to get the best possible response. And there are 5 generally accepted conventions of model agnostic principles that work towards improving our prompt. We can specify a direction, that is, describe a style in detail or reference a relevant persona. We can define a format, define what rules to follow and required structure of the response. We can also give examples to in the prompt. So say a diverse set of cases where you want the task was done correctly. We can also evaluate the response quality. We can identify errors, mistakes, and then rate the responses and probe the model to give us better response. Also, if we have a very complex goal or task, you can split those up into multiple steps and chain those chunks together. So in a way, you're iteratively probing the model to refine its response. One thing to remember is average prompts will return average responses. So when you put in your prompt, what it does, it changes the probability of every word that is generated. Okay, so is there a template that we can follow for effective prompting? And the answer is yes. There are several types of prompts. Here I've listed only 4, but if you're interested, you can go back and look at the different ways you can prompt the model, the LLMs. Discrete prompts are explicit instructions or questions that are directed to the LLMs, and they can range from simple commands to complex questions. Soft prompts are more about suggestions than direct instructions. So you can nudge a model towards a certain topic, tone, or style without being explicit. In-context learning refers to the model's ability to pick up on cues from the context that you've provided in your prompt. And in few-shot learning, you provide examples in the prompt to teach the model what output you're expecting from it. So by providing a few examples, the prompt guides the model into understanding the task and converting that task into a specified format. Now, we've gone over principles of prompting. We've seen a few types of prompting. Now, how do we next design effective prompts? Effective prompts need to be clear, relevant, specific, and well-balanced. So say you want your LLM to tell you a story. You can be more specific about what type of story you want the LLM to tell you. If you have an author, maybe the style of writing from the author, from your favorite author, and include what details you need from the response. Say conflict, climax, and resolution would be the structure. Also, say include relevant information. If you want to know, for example, historical origins of CPR, maybe ask for that. But then if you want to know how to perform CPR, be more specific. You can talk about, list the steps necessary to perform CPR on an adult, according to, say, the latest American Heart Association guidelines. But this doesn't mean that you make your prompt too detailed all the time. So finding a balance here is key. Remember that overly detailed prompts might restrict the model's creative potential, while overly vague ones might lead to more irrelevant information. Different wordings and structures can lead the model down different paths. So informal phrasing in your prompts may set a conversational tone. It may lead the model to adopt more casual and less technical approach. But if you want a formal response and a more professional tone in your response, it's better to word it either explicitly ask for that tone or word your prompt in such a way. Now, say you've got the response from the LLM. How do you analyze the response? When analyzing a model's output, you can often infer aspects of the internal interpretation by looking for subtle clues in the response. And here are some of the ways that you can do that. The model, say, is repeatedly focused and stressed on the response from the model is focused and stressed on certain details or concepts, suggesting that it's identify these key elements from your prompt. If one part of the prompt is emphasized in the output more than the others, then it's likely played a stronger role in shaping your response. Also, sometimes the output includes reasoning or details that are not directly asked for. So this extra information can reveal that the model has made connections or assumptions based on hints or context provided by your phrases or specific words. The structure of the answer, such as the order of presented ideas and the choice of examples, say the implicit reading patterns in your response, can show which aspect of the prompt the model interpreted as most relevant. Unexpected reasoning can become clear if the model uses analogies or explanations that weren't explicitly prompted, but seem to be derived from how the input was framed. Also, this ties into errors and biases. So if the output contains mistakes or biases, these may be traced back to ambiguities and unintended cues in your prompt. All right, so that was my brief presentation on the topic. We have gone over what prompt engineering is, principles of prompting, types of prompt, how to design effective prompts, and lastly, how to analyze responses. And I hope this will get you into exploring the topic a bit more. Thank you.
Okay, thank you, Shilpika. We'll now turn to Michael Burns.
Hi, everybody. You can see the screen, I'm sure. Yes, thumbs up. Looks good. You can see the screen. Hopefully. Yeah, sweet. Okay. All right. So I just wanted to go over a couple examples of things that I've actually used AI for. And in this context, I'm skipping over the machine learning stuff that I use for data analysis. We're talking in the context of the large language models. The big takeaway, of course, is going to be that it's useful for some things and not useful for other things. It gets squishy very quickly. And what these things are is going to differ as a function of the role, whether you're a student or a faculty in a classroom context, or if you're doing it in a research context, either as a student or faculty or teaching in those same things. So there's different dimensions to each one of these. Setting the stage for the things that I'm going to talk about, I teach a variety of courses. Cell biology, a weird course called Global Biological Risks, a course I teach with Dr. Vukov called Biology and Philosophy for the Future, and metagenomics. And metagenomics does double duty because that's also my research field. So we do some pretty good stuff there. But this does span quite a wide range of things. It goes all the way from like hippy dippy humanities stuff where we talk about feelings, all the way over to doing some pretty hardcore coding and everything in between. So I thought it would be nice to lay this out on a two-dimensional graph, because why not? I'm a scientist, right? So on the x-axis, we've got how good is AI at doing this? All right, how good are these language models at doing whatever the task is that we want it to do? They could be terrible, or it could be very good. It's very consistent. It's never perfect, but it can be very consistently good. And then on the y-axis, we've got how much does it matter if the AI is wrong? So some of these tasks, maybe it's bad at, but who cares? It doesn't matter. And some of them, maybe it's really good at, but it's kind of like, meh, but it really does. It's really important that it gets this decision right. So we'll just start with some examples. So in cell biology, which is like a course typically for undergraduates and usually their sophomore year, there's just some examples. I'm not going to go through all of these. Explaining basic concepts. So I explicitly tell my students, hey, if there's something that's in the textbook that you don't understand, and me explaining it to you didn't work, it's a perfect opportunity. Maybe you have a little conversation with ChatGPT or DeepSeek or take your pick of large language models and see if it can unpack that for you a little bit more. The good news is that for really basic concepts that are things in biology that we've known about for a very long time, AI is typically really good at explaining these basic concepts. It is important that they get the basic concepts right, which is why it's up in the upper right and not down at the bottom. But that is a valuable thing there. And I've had several students come to me and say that that works out. Other thing on here that I want to highlight, interactive practice questions for homework. Students, there's very clear literature in the pedagogy literature that recall for a lot of this stuff and being able to sort of read something and then being able to explain it to other people or sort of answer questions about it demonstrates that you actually know the material. And that's the big challenge. The old-timey way of doing that was to study in a group, right? So you can explain it to your peers and your colleagues, like, hey, I didn't understand this. Can you explain it to me? And then that person explaining to you it is able to actually reinforce their own understanding of it by explaining it to others. It turns out you can do the same thing with a large language model. It's kind of weird, but that's how that works. Another class. So here's metagenomics. This course is there's no exams, there's some quizzes, but it's mostly project-based, right? And these students are working on projects where they're doing large data analysis and coding. So for instance, when they're writing up a short manuscript or they're doing some coding, we have some things that AI is really good for, which is assisting with simple coding. It's fantastic for this. This has actually replaced a lot of like Googling through Stack Overflow to try to figure out something close to the type of thing that you want it to do. It's really, really good at this. This speeds up workflows tremendously. Same thing for formatting and editing text, right? So if you write something and you're like, it would just, your first pass draft looks like this, you might throw it into AI and say, can you shrink this down and clear it up a little bit? And it does really, really good at that. It's not crafting the text for you, but it's sort of pointing out like, hey, you used the same word 3 times in a row in each sentence. You should probably mix it up a little bit. And I love this because this dovetails off of what Shilpika was talking about last time. Up here in the area of where AI is not super great at doing stuff and it matters is generating multi-step code pipelines. So if you tell AI, here is my raw data, can you write a 500 line chunk of code to analyze it from beginning to end? It will do it poorly. It will do it terribly. And it's because there's too many steps. So what ends up happening in those contexts is you'll spend just as much time debugging the code for some giant multi-step pipeline that AI gave you as you would if you had just written it yourself by hand. The way around that is do everything in bite-sized chunks, right? You do it step by step, and you make sure that the input for this one makes the output looks good, and then you rinse and repeat and work your way through. And proper prompt engineering can help out with that. For research, it's absolutely terrible at writing research manuscripts and grant narratives. I would strongly discourage anyone from doing that. The literature is actually getting filled with people who are unfortunately doing that. Related to research, grant writing, and narratives, one thing it is really good at is over here is checking the alignment between the grant aims, or what a grantor is looking for, and what your proposal is actually proposing. So as a final pass, once you've got a rough draft of your proposal ready to go, it makes perfect sense to say, hello, AI model, here is my proposal. Here's what the funders look for. Is there good alignment between here? Is there something that I'm missing? And you'll go from there. Anyway, I'm out of time. There's a whole bunch of things that it's good at and bad at. We can talk about these more. Big point is that we're the intelligence and the artificial intelligence point, and I will leave it at that. Thank you very much.
Okay, thank you, Michael. I'm sorry to have rushed you a little bit. Okay, and Joe, you're next.
Yeah,
Last
everyone's
but
getting
not
this.
least. Okay.
Thank you, George. PowerPoint coming through good? All right, thanks everybody. So I'm the ethicist on the panel. So I'm just going to give you a quick overview, and I want to make sure we leave some time for Q&A and discussion too, of what the ethics of AI looks like in a globalized world. And this is going to be very much a 50,000 foot kind of view. I could have also titled these comments some notes from Antiqua et Nova. If you haven't seen this, so I do Catholic informed philosophy and some moonlight as a theologian sometimes. The Vatican just released a really interesting document on the ethics of artificial intelligence just a couple of months ago. Even if you're not Catholic, I would really recommend taking a look. It's available online. It's only 20 or 30 pages, so it's pretty quickly, and I think does a really good job. And a lot of my comments today are inspired from that document, and I'll even be including some quotes here too. So I think when thinking about the ethics of AI in either global or local context, it's helpful to take three different perspectives on it. And I'm going to walk through each of those three perspectives really briefly today. The first one is ethical considerations coming from what kind of thing it is that we're talking about when we're talking about AI, and my previous panelists have done a great job of introducing you to what AI is. What I want to just talk through really quickly is some of the ethical issues that come out of once we understand what an artificial intelligence is. Second perspective is how do we use it? We've also started talking about that. And the third one is one that maybe we haven't talked about quite as much, but it's this question about how does my use of it affect me? I think this framework is actually good for any kind of technology, understanding what it is, understanding how we use it, and understanding how it affects us. So this isn't just an AI framework. This is in any technology, any tool framework, but one I think that is particularly helpful for AI. So first of all, what is it? My gloss here is a little different than what other people have said, but I think that I'd be happy to concede the definition to those who know better on this panel. It's a machine that makes predictions built from training data. So it's a very broad definition, but right, you've heard already sort of what it looks like, especially from Dima's early comments, how exactly you build a machine learning model, and you're using lots and lots of data that's able to recognize patterns and make predictions based on that data. One upshot of this is that it's a ongoing problem with AI is that it's subject to biases. Why? Because the data that we train an AI on has biases in it. It's human-generated artifacts, and the fact that it's human-generated means that it's fallible, because we're fallible. So even if you have the best of intentions, it's actually really hard to rid AI of biases completely. Sort of a notorious case of this was an AI that was being used to determine parole terms for people for a prison system. And if you look at the data here, you'll see that the system was overestimating the degree to which Black offenders would reoffend and underestimating the degree to which white offenders would reoffend. It's interesting if you read up on this, we can talk about it more, or if you're really interested, you can email me and I can send you some of these studies. The story behind this is the people putting this together had the best of intentions going in. They weren't trying to make a racist parole AI system, but because the data that they trained it on had implicit biases in it, it wound up being a very biased system that they wound up with. Another, I think, really globally important aspect of ethics that I think is important that we're aware of once we understand exactly what an AI is Dima introduced to us with the DeepSeek caveat, but that a lot of AI models are really, really expensive to build. What's one of the upshots of this? It's that ownership of big models tends to be concentrated in the hands of a few. Why? Because there's a lot of money it takes to build them. And we're seeing sort of this consolidation happening right now where big companies, the rich get richer, the poor get poorer sort of thing. And at an economic scale, on a global scale, that's obviously something really important that we're aware of, is that it's not just this very democratic sort of thing in which any of us can build a model for whatever's in our back pocketbook. It's that it takes a lot of resources and a lot of money to build big and effective models. And because of that, you get this kind of, I don't want to call it anti-democratic, but sort of a consolidation of AI power in the hands of a few. And the last one, we could talk about all this stuff for a long time. It turns out that artificial intelligence is not the best for the environment. Any of our technology has an environmental effect, but AI use is even more of an effect on the environment than just standard internet use. Somebody could correct me if I'm wrong. I've heard the quote that a typical ChatGPT search takes about 10 times the amount of energy of a Google search. That might be sort of a rough estimate, but it is something to be aware of, that as we're building more and more data centers, these are not carbon neutral. They actually have an environmental cost. And when we're thinking about global perspectives, that's a really important one for us to think about, that this development doesn't come environmentally free. I'll be quick on these next two, George. Make sure we get good time here. Second perspective. So we talked a little bit about what is it, and I think understanding what it is as a tool helps us think through a few important ethical issues. There's also ethical issues that come up with how we use it. And we've talked about this a little bit already. I'll let you read this quote on your own as I talk through this. This is again, it's coming from Antiqua et Nova, but this is something that ethicists have been thinking about a lot, is that depending on our use of AI, it can use to, and this is a technical term, but it's one that you should be able to get because it's a well-chosen technical term, it can use to de-skilling. What's de-skilling? It's roughly taking something that used to be a skill that humans could perform and swapping out with something that an AI performs instead. Obviously, this is not just for AI. Technology in general leads to de-skilling. The invention of the computer led to the obsolescence of typewriter repairmen, right? So de-skilling happens with any technological advancement, but it's something that AI is we're kind of currently figuring out where the de-skilling is happening, where the jobs are increasing, where the jobs are being lost. George started out in his opening comments saying he's not particularly concerned about this. I think sometimes it does get overemphasized, but at the same time, I think it's obvious that there's certain ways in which the global economy is going to shift because of AI. One that I think is just a really obvious one, AI-generated video is getting better and better. OpenAI's Sora is sort of one of the big ones, but there's going to be other ones coming out as well. And people have said one thing this is going to do is lead to the obsolescence of stock footage makers. Why? Because if you want a little bit of stock footage of something, it's really, really easy to just generate it using artificial intelligence. So if you're a stock footage videographer, you might have to broaden your horizon. So there's going to be different parts of the global economy that are just inevitably going to be affected. And obviously that's an economic issue, but it's also an ethical issue as well. The last question, again, is one that I think is a really important one, and one that a lot of times doesn't get discussed, but it's one as a philosopher I just wanted to throw out there, is that there's this question of how does the integration of AI with everyday life affect me personally? This is coming from Antiqua et Nova. I think it's a really nice quote. Non-quantifiable aspects of life are set aside and then forgotten or even deemed irrelevant because they cannot be computed in formal terms. There's 101 examples that we could give of this. One that I particularly like is the example of how we used to and how we today get book recommendations. Just 10 years ago, if I wanted a new book recommendation, I finished the one that's on my shelf and I want a new one, I might ask my friends, Michael and Shilpaka and Dima and George, for a recommendation, and they would give me one. And it might not be the one I would have picked. It might be outside of my interest, but I think, oh, George is a cool guy. I'm going to read this recommendation. How do many of us get our recommendations now? Well, if you're like me, you a lot of times will get them from Amazon. You buy a book, and then all of a sudden it says, you can see I actually wasn't looking at books. I was looking at board games, but it might say, here's what you should look at next. And you think, oh, that does look kind of good. So you take that. Now, what's happened, nothing ethically hugely problematic, but what has happened is that there was an aspect of my life that used to rest on non-quantifiable friendship, in particular book recommendations. And because of the integration of, in this case, a fairly simple AI, just a predictive AI that's predicting what other books I might want to buy, that I've swapped that out with a quantifiable recommendation and given it over to an algorithm. And I think there's very few cases in which these decisions are problematic in themselves, but compounded, I think we really can start to chip away at our humanity if we start to rely on AI for formerly human tasks and instead letting algorithms choose those things and make those decisions. And in this case, swap out a relationship that used to be there. Those are my comments.
All right. Well, first of all, I just really want to start by thanking all of my panelists for really setting the table so wonderfully. And we now have time for questions. And I'm gonna first turn to the chat to see if anybody wants to throw a question in there, but if not, I have some questions that I'm prepared to ask. Let me give just a few seconds for that. All right. And seeing that I don't have a lot of questions yet, I'm gonna go ahead and warm things up here by turning to one of my questions that I have here, and if you could just give me one moment, please. Okay. And the way that we're going to do this is the panelists could just jump in, you know, as they see fit. I think I'm going to start actually with this first question, which is, how do public perceptions and understandings of artificial intelligence differ from those of individuals who work closely with AI technologies on a regular basis? Because we have quite a few people here working with AI on a regular basis. In fact, almost everyone on the call. So why don't we start there? And and I may actually just turn to one person to start this, but you're free to I was thinking I might actually ask DMI to jump in on this one first, but it could be open to anyone. So
Before we continue, I think it says the chat box is disabled. Somebody, I don't know if you see the Q&A.
Actually, wait, there's a Q&A thing now.
Yeah, I've never seen it before.
I think that's where it's supposed to be. Okay, so I am seeing the Q&A. So I don't know, maybe Mary and Fraser can look at that, but maybe one of these is for us and the other is for the the audience. So I'll get to a question from the audience in a bit, but let me start. So did you get that first question? So basically like how we perceive it versus how the public perceives it at this stage.
Yes, that's a very interesting question. I feel like in the past, I always felt like the public significantly overestimated where AI was. However, now I feel like people significantly underestimate where AI is at. I feel like AI is much further, much closer to things like AGI and even ASI now than people realize. So that's my short answer, but I would love to hear other thoughts from other people.
I have a quick thought. That's really, I want to actually hear more from Dima too. I want to hear why he thinks that we're close to AGI and ASI. As an ethicist, I think one thing I see is that people think that ethical questions often are limited to use of large language models like ChatGPT. And there are some really important ethical questions with that. But I think a lot of times people will ignore the fact that AI is integrated into all sorts of other applications. So things like I mentioned parole decisions and educational spaces and data space. There's sort of all these other spaces too that AI is also integrated. And there's also really important questions ethically that we need to be asking in those spaces as well.
I have plenty of other questions, so you're not all obligated to jump in on this one, but did I get to everyone who wants to answer this one?
I just wanted to add that I feel there is a gap between the communication between researchers and people who work with AI and the public out there. So if we could bridge that gap, one of the reasons why I see there's a gap is even researchers don't have answers to the questions, and we don't fully understand the black box that is an AI. And we are trying to figure it out. We are trying to make it more meaningful, the responses, but then again, AI LLMs tend to hallucinate, and we don't know why exactly they do that. And once we get there, I think this gap will be bridged, maybe not fully, but then it will take time. And until then, I think it's very important for us to keep the communication open and be transparent about where it is going, where it is headed, and what challenges we are facing. And that would be a good first place to start.
I think Michael unmuted himself.
I did unmute myself. I think instead of maybe we can dovetail, I think, from that to two questions that we actually have in the Q&A box. So Sunny asked about insights regarding integration of AI tools into the curriculum university-wide, so and again, I'm interpreting curriculum as separate from like on the administrative side for like admissions and all sorts of other stuff, which is
curriculum, yeah.
So in the curriculum, and then there's a follow-up question here, which I'm not sure everybody can see all the Q&A, but Paula asks, agreeing that it's not going to go away, but what about like the dilution of language and the fact that people think that good grammar now equivocates to like AI generated good grammar because it's very polished or can be. And the concern about students not developing the appropriate skills that they're intended to develop when you're in a course, right? So in other words, as a technology enthusiast, like writing is an essential skill, and it seems like it could be being undercut by the utility of this. Forgive me, Paula, I'm paraphrasing what I think your question is. And I think that there's two things to highlight about that. The first one is something that Joe was talking about at the end of his talk, which is de-skilling, although there's more technical language we can use for this. So I forget, I'll have to dig up the article on it, but the idea of technology as a cognitive artifact. I love talking about cognitive artifacts, so bear with me. A cognitive artifact would be something like an abacus, right? An abacus is a cognitive artifact where you use an abacus to do add and subtract numbers, etc. I don't actually know how to use an abacus, but I've heard that people use it very efficiently to the point where the utility of that tool, actually at some point you don't even need it. Apparently you just have a model in your head of an abacus, and that actually increases your ability to do mathematics, which is super cool. So that is a type of cognitive artifact, but it is an artifact that is cooperative. It's cooperating with your skills to make you better at what you do. Another one would be like a bicycle, right? A bicycle is a great way to like get from point A to point B. You're still having to exercise. You're still having to use your skills to get from point A to B, and it's just cooperating with it. There are ones that are negative, where these are competing cognitive artifacts, where the thing is doing the work for you, which means that your skill and that totally atrophies. And the most obvious one for people of my age generation is GPS. So GPS is a cognitive artifact where like no one knows how to use a paper map or orienteer anymore because you just put your earbuds in and like it's said to go left and then you just go left and you never have to worry about it. It's actually destroying our ability to orienteer completely. And the concern especially for folks in the humanities, because these language models are able to craft language and dissect texts and summarize them and so forth, is that if you're using them in a curriculum, if you're rolling them out university-wide in the curriculum, whoever's doing that and whatever that context is going to be, you're going to have to pay very, very, very close attention to whether or not the cognitive artifact that you're providing to students is going to be co-opting or undercutting or competing with their ability to actually develop the skills that you need, which is like, again, the intelligence on top of that to make sure that the output of AI is actually valid. I will get off my soapbox now. I'm done.
Oh, that's perfectly fine. This is kind of an opportunity to be on the soapbox. I do want to point out that I know how to use an abacus. Although I do want to point out that historically the abacus was originally used by drawing lines in the sand. So technically, you just have to have a beach to go to use an abacus. But we do actually have a few more questions here. That have queued up. I'm trying to, some of these are pretty deep questions. I do apologize if we don't get to all of them. I want to actually spend a little bit of time talking about this misinformation question, because I think this is something that is particularly timely and important. Now, again, framing this in the context of, AI is not the first place to get misinformation from, because we've had social media for some time, and even the recommender systems example that Joe gave us is not something that comes from the same technology as in these LLMs, actually. So I'd like to ask our panelists, just what are your thoughts here on, how we can if you will, have some guardrails in place when it comes to misinformation, and how can fact checking be incorporated? So I, think that is something that's kind of there are two questions in Dan's questions here, actually. So take it away. And this might be the last question we get to, given our time. So.
Shilpika, can I just use a prompt to say, don't tell me things that are not true? Does that work?
You could, but then it again depends on the model.
Right.
If it's not a good model, it's going to give you bad answers. But models are getting better nowadays. The people who train them have learned from their past mistakes. There are so many guardrails set up, but then the person who's prompting them, if they have an intent, malicious intent, they will somehow get their way around those guardrails and then figure out a way to get the response. So this is why I think it's very important for us to focus on model interpretability and explainability. We can't really, because these models are getting bigger and bigger and more complicated, but then they still remain a black box to this day. So we need to focus on that aspect for us to completely get rid of misinformation, if that is possible. But otherwise, we will always have misinformation. This is why I feel all these LLMs are a tool and not a replacement for people, because we don't know when they will give us the wrong answers. So it's always useful to understand that this is a maybe answer, a maybe response, this may be false. So that's my opinion on the matter.
Yeah.
I think one.
I think also how you phrase a question, if you go back to Schulberger's prompting strategies, so try not to, you definitely want to try not to bake your own bias into questions that you're asking, because this is going to give you, so bias also has a lot to do with us, because we are human, and we're very good at bias already.
I think one thing that's helpful, not for eliminating misinformation, but for becoming more aware of it, is sort of familiarizing yourself with what AI is. So I think this panel is a really good example of that. I think Dima's slide on how is an LLM trained a chunk of the internet. And we know, although the internet is full of only truth, right? That was our cat, right? We know that it's not. We've talked a little bit about the black box effect. So I think sort of knowing a little bit about what kind of tool you're using can be really helpful, not for necessarily eliminating the misinformation, but sort of realizing the limitations that it can have. I think we all have that literacy, or many of us have that literacy with the internet now, where we realize not everything on the internet is true, and there's, this website is more trustworthy than that site. And I think attaining that kind of literacy with AI will be really helpful as well.
Okay, well, regrettably, we are out of time. This almost inevitably happens, especially when you have such a great group of panelists. There's a lot to say here. I do want to let everyone know that this is the first of a number of webinars that we're going to actually be holding. And so I hope that all of you who joined today will be able to join us for one of the future installments. Again, thank you so much to the panel. Thank you to the organizers, and have a wonderful day.